there we go. All right, so question number 1 asked us to draw a picture. So you got your leading strand here, goes towards your helicase. You've got at the beginning of your leading strand, you've got your DNA polymerase 1, and it ends on your DNA polymerase 3 alpha subunit. Back here, you've got your lagging strand. You've got your DNA primer or primase. And each one goes right here, filling in the gaps with the template, and then it gets filled in with the Okazaki fragments. What else is there? These are always going to be 5 to 3 because the original strand is 5 to 3 on this side. And yeah, and you got your gyrase just beyond the helicase, which is also your topoisomerase.
Your origin is right in the center.
Oh yeah, and your origin is right down the middle, right down the dotted line. For number 2, we got the first one, DNA primase. B, we got DNA A. Number 3, or C, we got DNA polymerase epsilon. For D, we got DNA polymerase 3. For E, we got TUS. For F, we got DNA polymerase 1. For G, we got DNA gyrase or topoisomerase. For H, we got ORC or origin recognition complex. For I, we got SSBP, sorry. And for J, we got DNA ligase. There's that. 3, list 5 enzymes, prokaryotic or eukaryotic, that consume ATP. We got DNA helicase, DNA AA, DNA gyrase or topoisomerase, DNA ligase, and DNA primase. For part B, list 5 enzymes. We got DNA polymerase 1 and 3, alpha, delta, and epsilon. For 3C, we got for the exonuclease activity, we got DNA polymerase 1, 2, 3, delta, and epsilon. For part D, involved in replication that uses DNA as a template to synthesize RNA. That's just DNA primase. And the one enzyme that uses RNA, we thought it was DNA polymerase 1, but it's actually telomerase. And yep, that's it for that one.
For question number 4, it really helps to watch the video that the teacher put out there. It helps you understand it better. But given your DNA molecule or DNA strand that they give you, and then the primer, you have to remember, is the beginning part of the replication. And remembering always that the 3' goes next to the 5' while the 5' goes next to the 3'. So you know that you have to flip the primer around. So you have the 5' starting it essentially at the back of the 3' of the original. And you kind of figure out where it ends. And so it ends where it goes CCTTAAGCA. That's all of your primer section, which we don't need to include in any of these. So then if you look at the first one, the first section is you have all 4 nucleotides. So you can just replicate the whole strand of DNA there. So you write the opposites there. It's ACT, GAT, GGT, CCT, GCTAT, going 5' to 3' on that one. So then you look at the second one, and you don't have cytosine. So the first time you come across a cytosine, you have to stop the replication there. So you take your primase, you take your primer there, and then you have a T, which goes to an A. Then you need a G that goes to a cytosine, which we don't have. So that's where it stops. You have 5' end is A, and then you have the 3' end is right after the A there. For the third one, we do have cytosine where you have uracil this time instead of thymine. So the first time you come across an A that needs to be replaced with a C or with a T, you can't do that as well there. So you go through the same process there. You have your primer, and then you have your T that goes to an A, your G that goes to a C. Then you have an A that would go to a T, but you don't have thymines again, so you end it there. So it's 5' is your A, then you have a C, then you have your 3' end there on the C. So for the last one, your G is what's messed up. So the first time you come across a C, that's where you have to end your replication there. So you've got your primer again there, and then you have T that goes to A, you have G that goes to C, you have A that goes to T, and then you have a C that should go to G, but again, we don't have it, so that's where it stops there, so you just have ACT. And there's your answers again on that one. For the last one, the proteins found in prokaryotes is going to be DNA gyrase, DNA primase, polymerase 1, and polymerase 3. For which ones are found in a mouse, or normal house mouse, we have CDC6, we have polymerase, MCM helicase, polymerase alpha, telomerase, PCNA. For C, which are in the chromosome compaction, it's DNA gyrase or topoisomerase 3 or 2. For D, which ones are involved in the initiation stage, you have DNA A and you have CDC6. And for E, involved in termination are TUS and telomerase. And there are the answers again on that one.
And yep, those are our answers. Thanks for watching.